In this video, we're going to talk about solving linear inequalities. When we talk about graphing linear inequalities in one variable, it would be something like this, where we want to graph the situation where all real numbers are greater than -4. So we're going to start with our number line. I'm going to put -4 in the middle because really that's the number that I'm talking about. Then I'm going to give some numbers on either side just to give a frame of reference. Remember, when we're talking about negatives, if -4 is here, -5 would be here, -3 would be here. I want all numbers greater than -4. So I want all of the numbers that are greater than -4 and as close to -4 as I can get, but I don't exactly want -4. So how I'm going to show that on my number line is I'm going to do an open circle at -4. Then I get to color. I'm going to shade all of the numbers that are greater than -4. So that would be everything on this side of my number line. And I'm going to make sure to shade my arrow because it does continue forever in that direction. This tells me that all of these numbers in the shaded regions are solutions to this sentence. So I want every single number that is as close as I can get to -4, so -3.99999999999, so on. But I don't want -4, so that's why I have to have an open circle there. The next one says all real numbers less than or equal to 3. I'm going to start off the same way. I'm going to start with my number line. I'm going to put 3 here. Remember, I'm on my positive side now, so that would be 2. This would be 4. I want all numbers less than or equal to 3. So this time I want all of the numbers that are as close to 3 as I can get and including 3. So I'm going to start with that same open circle, but this time I'm going to close it in because I want to include 3. That's my equal to. And then I want numbers all of the less than 3, so I want everything on this side of my number line. So I'm going to shade that side of the number line, and I'm going to shade my arrow because it keeps going forever in that direction. Solving linear inequalities is exactly what we're doing today. Solving linear inequalities is the same as solving linear equations. You're not doing anything different. There's only one new thing that we have to add, and that is when you multiply or divide by a negative number, you must flip the inequality. Here's why. Let's take a look at how negative numbers, just a simple inequality. If I have -1 times x is greater than 4. Let's say I don't flip the inequality. Let's say I divide by -1 because that's how I would solve this. I would divide this by -1 and divide this by -1. And I would get x is greater than -4. So we're not going to flip the inequality yet. Let's go and check that. So if I were to graph that, I would say, okay, -4 is here, -5 is here, -3 would be here. Before we finish our graph, let's go and check this. So let's pick a number that's greater than -4. Let's pick, say, 0. So I'm going to test this. Actually, let's not pick 0. That's a little too easy. Let's pick x is equal to -3, since that's right next to it. And I'm going to plug that in here. So I have -1 times -3 is greater than 4. Remember, multiplying by -1 is really saying the opposite of this number. So I want to say the opposite of -3. -1 times -3 gives me 3, and that's greater than 4. Wait a minute. That's not right. 3 is not greater than 4. Okay, well, let's test x is equal to -5. That's on the other side of my 4 when I look at my number line. So when I test that, I get -1 times -5 is greater than 4. Well, that's true. 5 is greater than 4. So I have to flip this inequality to be less than when I divide by that negative because of how my number line works for negative numbers. If I'm here at -4 and I'm going to multiply, I'm going to take the opposite of a number and I want that to be greater than 4, then I have to take all of the numbers that are on this side of my number line, not over here because that doesn't work. So I'm going to open circle there and shade everything that way. So let's take a look at a few of these. Again, remember what we said, solving these is no different than solving an equation. So if I have x plus 8 is greater than or equal to 1, it's exactly like solving x plus 8 equals 1. Well, if I have x plus 8 equals 1, I'm going to subtract 8 from both sides. I'm going to do the same thing here. And I would get x is greater than or equal to negative 7. Okay? The directions do ask me to graph, so I'm going to graph that on my number line. I do need to show numbers here, and I do need to show how my numbers are going. Greater than or equal to means closed in circle. And then I want all of the numbers that are greater than or equal to negative 7, so that would be all the numbers on this side. I can check these, and you know what I say, if you can check them, you should. So pick a number that's greater than or equal to negative 7. You don't want to choose the number that's equal to because that's going to be equal to regardless of your inequality. So pick a number farther down the line. I notice since I'm going this way, 0 is certainly in my solution set, and so 0 would be the easiest one to plug in. Eight is indeed greater than or equal to 1, so I know I have the correct solution. B, I've got negative 2.5y is greater than 3. To solve this one, I'm going to be dividing since I have multiplication, just like if it were an equal to sign. So I'm going to divide by negative 2.5 on both sides. Hang on a second, warning, 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 I'm dividing by a negative, so that means my inequality has to flip. Then 3 divided by negative 2.5 gives me negative 1.2. I'm going to graph that on my number line. Negative 1.2 would be here. I'm going closer to 0, so this would be negative 1.1, and this would be negative 1.3. I want to stay consistent with my numbers, so if I've got a decimal here, I'm going to go ahead and use the decimal here. Less than, no equal to sign, so that means open circle. I don't want my circle filled in. I want to get as close to that number as I possibly can. I don't want to include it, and I want everything less than that, so that's numbers over here. I'm going to do my check. I'm going to test with, y being negative 1.3. So if I have negative 2.5 times negative 1.3 should be greater than 3. And in fact it is, it's 3.25, which is greater than 3, so I know I have my correct solution. For C, we get a little bit more complicated. So this time we have a two-step inequality. Again, just like if I was solving an equation, I would add 3 to both sides first. So I'm going to add 3 to both sides first here. My inequality stays the same. That would give me 15. Then I'm going to divide by 5. 5 is a positive number, so I don't have to worry about flipping the inequality. That's going to give me x is greater than 3. I do also need to graph this one. So I'm going to have 3 here. 2 would be here, 4 would be here. Open circle on 3, and I want everything greater than 3. I still need to do my check. Let's check with x being 4. So 5 times 4 minus 3 should be greater than 12, which gives me 17. And that is greater than 12, so I know I have the correct solution. D, here we have an inequality where we have variables on both sides. Just like if this were an equation, my first job is to get those variables on the same side. So I'm going to take this minus x, and I'm going to add x to both sides. That gives me 1 is less than or equal to 4x plus 21. And now it's exactly like I did on C. Subtract 21 from both sides. That gives me negative 20 is less than or equal to 4x. Then I divide by 4. Keep in mind, I do not flip my inequality here. I'm dividing by a positive 4, so even though 20 is negative, I'm leaving my inequality the way it is. So I get negative 5 is less than or equal to x. When I go and graph this, I know my reference point is going to be negative 5, and over here would be negative 6, and over here would be negative 4. I know because I have less than or equal to symbol that I want to include that -5 in my answer, so I have a closed circle. Now I'm not sure, which should I shade, -6 or -4? Start from your variable and read the inequality. X is greater than or equal to -5. Well, if X is greater than or equal to -5, I'm talking about this side. Check it to make sure. Let's pick X being -4. So here I'm going to have negative of -4 plus 1 is less than or equal to 3 times -4 plus 21. That gives me 5 is less than or equal to 9, and that is true, so I'm good. And I know I have the correct answer. Second one, you start growing geraniums from seed and plan to sell potted plants for Mother's Day. It costs $1.75 to pot and grow. So my costs are $1.75 per plant, and I'm going to sell them for $3.25. I want to know how many I need to sell if I want to make a profit of at least $150. So I need to write my inequality first. I know that I'm going to sell them for $3.25. So that's going to be $3.25 times the number of plants I sell. Say I sell 5 plants times $3.25, that's how much I make. But it costs me $1.75 for every plant that I sell. So I'm going to subtract that from what I'm making. Then that number, this number that I'm making, my profit, I want to make a profit of at least $150. So a minimum of $150 means I'm going to have greater than or equal to 150. From here, I combine like terms. 3.25x minus 1.75x gives me $1.50x. So for every plant I sell, I'm making $1.50 in pure profit. And I want that to be greater than or equal to 150, so I'm going to divide by 1.50. So that means X has to be greater than or equal to 100. So I need to sell at least 100 plants.